Welcome back, everyone. This will be part 6 of our introduction to insect taxonomy. And today we're going to be moving on to the crustaceans, which are the closest arthropod relatives with the hexapods or the insects, not counting the entonaths. So, if you will remember from our original talk about the phylum Arthropoda, we have the two main groups, which are the Chelicerata, which these are the spiders and friends, and the scorpions and all those fun things, and they have chelicerae, which are mouth parts that move up and down. And then we have the Mandibulata as the second group, and these are the insects, the crustaceans, the centipedes, the millipedes, and they have mandibles, which are mouth parts that scissor together side to side. And they have many other distinctions, but that's how they're named. They're named for the chelicera and the mandibles. Last time we talked about the myriapods, which are the centipedes and millipedes, and their relatives. So the things that go through anamorphosis, they have a head and many segments, each of the segments containing a leg. They don't really divide easily into tagma, so you don't have like a distinct thorax and abdomen like you do with the insects and the crustaceans. And today we're going to be talking about Pancrustacea, which are the crustaceans, which is a paraphyletic group, which is not it doesn't wholly encompass everything. The name doesn't wholly encompass everything within the evolutionary tree of the Pancrustacea. And then it also includes the hexapods, which are the insects, and the entonaths. So this is what, I used a different typed out font because things are getting very complicated now in the evolution of things. This is what the Pancrustacea evolutionary tree looks like when we're talking about the extant species. So these are all of the species that are not extinct. These are things which are currently alive on Earth, or these are the classes of things which are currently alive on Earth. So this is the Pancrustacea, which is a very confusing name because not everything in this group is a crustacean. So the other name that is frequently used, and which is honestly a better name, is the Tetraconata. And Tetraconata refers to the structure of the eyes of this group of animals. Tetra meaning four, and conata referring to cones. So these are the four cones in the eyes. So cones are what animals use to see. Cone cells are what animals use to see color. Humans have three. All of these creatures have compound eyes, and all of them have four cones within the eye units, which are called ommatidia. So they're sometimes referred to the Tetraconata, and honestly that is probably what they should be referred to, and not the Pancrustacea. Today we're going to be specifically talking about the groups of crustaceans. And I've said this before, that this is a paraphyletic group. The Crustacea are, the crustaceans are a name that refers to the majority of things within this branching system here, but not all of them, which is why it's paraphyletic. As opposed to monophyletic, which would mean everything on this evolutionary tree is a crustacean. So to talk about what crustaceans have, what is a crustacean? So we have the crustaceans. I can't remember how to spell crustacean. Crustacean, crustacean. Spelling was never my strong suit. So we need to talk about what are the characteristics of a crustacean, right? So, and what differentiates them from like insects and spiders and all that other stuff. So they have an exoskeleton, just like the insects and the spiders, which they molt. They have a segmented body, just like the spiders and insects and things like that. The difference between like spiders and crustaceans is crustaceans generally have three segments that are sometimes fused into two. So it's the head, the thorax, and the abdomen, but sometimes the head and thorax are fused together like in spiders and you end up with a cephalothorax and abdomen. But it just depends on the group. They have jointed legs, just like all the arthropods, but they generally have kind of a unique set of legs. They all have at least one biramous appendage. So they have biramous appendages, which means that instead of like an insect leg, which is, or a spider leg, which is, comes to one point, biramous appendages are kind of clawed, and it splits into two parts on each leg. And that's, so like their, crab claws and Shrimp's legs will frequently split into two. That's called being biramous, and that is something that is unique to crustaceans. They also generally have gills, as opposed to book lungs like in spiders or a tracheal system like in insects. Crustaceans usually have gills. Sometimes they'll have modified gills if they're living on land, but they generally have a gill system. And also going along with that gill system, they usually have some sort of oxygen-carrying pigment in their blood. So insects rarely have oxygen-containing pigments in their blood. Generally, their blood doesn't transport oxygen at all. It's just used to transport nutrients and to transport cells in their immune system and things like that. But in crustaceans, they actually have either hemoglobin, like mammals do, or they have like a hemocyanin, which is a different. I believe is that copper or is it nickel? I can't remember. That is instead of iron, that is used to bind oxygen and transport it among the body throughout the body. So when we talk about crustaceans, we're talking about these general characteristics, and those characteristics don't apply to everything within the Pancrustacea or the Tetraconata. Specifically, these are crustaceans, these are crustaceans, these are crustaceans, and this is a crustacean. And that's what I mean by paraphyletic. It does not include this part. Let me change color. It does not include this part of the tree here. These are the hexapods. And the hexapods are the insects and entonaths. So the insects don't generally have gills. Some of them do have a tracheal gill system, but those are secondarily evolved. The archetypical insect does not have gills. The insects do not have biramous appendages. Insects do not have oxygen in their blood. They don't have blood that can. Generally, they don't have a pigment in their blood that can transport oxygen. Some of them evolved this secondarily in order to deal with extremely polluted waters and things like that, low oxygen systems. And they don't have they never have a fused cephalothorax. It just doesn't happen. They have three distinct segments. And additionally, crustaceans may have many, many legs, multiple legs. Insects only have three sets of legs. So there is a difference there. So that is why crustacean is a kind of a weird term, because it does have this big hole in the middle of it where it doesn't apply to this group. So we're going to talk about all these other groups: the Brachyneura, the Ostracoda, copepods, Taxonomy, Malacostraca, Brachiopoda, the Remipedes, and the Cephalocarida. And we're just going to briefly touch on these things. If you are very interested in crustaceans, feel free to learn more about them. I don't know a ton about them, although I am very interested in them. I haven't really put in the work to learn a ton about them. Generally, people that are interested in crustaceans are interested in these, the Malacostraca. A lot of these other crustaceans are very small. Many of them are microscopic, so they're not exactly the easiest thing to work on, but we will go through them. So first, let's talk about the crustaceans. So as you are aware, the crustaceans don't just include the crabs and lobsters. They include lots of other things that we just talked about. They have a lot of these very small microscopic organisms here, like the copepods. They also include the barnacles and the sea lice and things like that. So they're very, very diverse. There's about, the crustaceans make up about 67,000 known species. And there may be, between 600,000 to 6 million. We're not entirely sure. But the insects are still the bigger group with an estimated 10 million and a currently 1.5 million-ish known. So relatively, for this giant tree, the insects and the hexapods are still by far the largest group within this tree. But the crustaceans are very diverse. But we will start with the Cephalocarida, which are a very, very small group. There's only a handful of species known in this group. Oh, one thing that I did want to say with the crustaceans before we get to the Cephalocarida is that the other interesting thing that the crustaceans all have is a larval stage. Not all insects have a larval stage, but all crustaceans have a free-swimming, sometimes called the nauplius stage. These are free-swimming larvae that are very, very small. If you ever wondered what a baby crab looks like, they're generally microscopic. But let's get into the cephalocarida. So the cephalocarida, this reminded me of the larval stage because they do have a larval stage, and they're very small. There's only about a dozen known species, and they are generally itty-bitty, like half an inch or less. And you will find them free swimming in the in ocean water and the things like that. But they're extremely, extremely small. And I'm not going to spend a ton of time talking about these because there's very few species of them known. Additionally, we have their close relatives, the remipedes, and they are also very, very small. They are blind, they are clear, and there's only about 17 species known. So there's 17 species of this. These are the remipedes species. They're all blind, they're all clear, and they all live, generally speaking, in tropical oceans. You can find them in all the oceans, I believe, but they're more common in the tropics. You can see their biramous appendages here. They have tons and tons of legs. I want to say it's 20 plus segments on all these species, but they just swim in the water column. And again, they're very, very small. They're generally less than half an inch. They're 1 to 4 centimeters. 1 to 4 centimeters, but they're generally closer to the 1 centimeter than the 4 centimeters. Very, very tiny. Not a ton of diversity in this group, and you probably have never heard of these. You will probably never see one in your life. But they do exist, and you should know they exist, and they are relatively close relations to insects. The other very, very close relation to insects are the brachiopods, which are referred to as the fairy shrimp. And you can actually probably find these near you. So the fairy shrimp live in both saltwater and freshwater, and they're very common in freshwater lakes and things like that. If you take a good net and or a bucket and scoop up the sand at the bottom of a lake or a river or whatever, and start going through it, you may find little clear shrimp-like creatures living in there. Very, very common, and these are just the little bitty fairy shrimp. They generally feed on plankton. Even in freshwater, they generally feed on plankton. Very, very small. There are many, many species of these. We're not going to spend a ton of time talking about them. They generally exhibit like 20 plus body segments and swim around free swimming. I think they're all free swimming. I don't know of any that are parasitic, but there are many parasitic crustaceans, so I just wanted to bring that up. But these live all around you in fresh water, and if you go looking for them, you will find these brachiopods. So we're not going to talk about taxopods today because that's the main focus of this course, so we'll skip over, and we'll talk about the Malacostraca. The Malacostraca are what you think of when you think of crustaceans. The Malacostraca are the lobsters, the shrimp, the crabs. All of these are Malacostraca. This is the largest group of crustaceans. There's something like 40,000 plus species of these. I believe they're all aquatic. I don't know. Well, I'd say that there are terrestrial Malacostraca, so that's not true because there are terrestrial crabs. Like the coconut crab, it's generally terrestrial, and they have a modified air gill in order to sustain themselves on the land. But the majority of them have an aquatic stage. So even things like the coconut crab does have to lay its eggs in water. But these are the shrimp, the krill, the prawns, the wood lice, the amphipods. This also includes the pill bugs or the bill bugs, the roly-polies, wood lice, things like that. So these are, when you think of crustaceans, the Malacostraca are what you really are thinking of. They're the very large crustaceans. They're found in all of the oceans. There's lots of freshwater species of these when you're talking about the crayfish. Lots and lots of things in the Malacostraca group. You should be aware that that other crustaceans exist though, because this is probably what you're thinking of. This guy here is a fairy shrimp, the guy with the supersonic punch that can boil water. If you're not familiar with fairy shrimp, they're super colorful. They're dangerous to keep in aquaria because they can punch through the glass. I think they can punch faster than the speed of sound, and that's how they subdue their prey. They can boil the water on their prey. Pretty cool creatures if you've never seen them. And being tetraconata with all these extra cones in their eyes, they can see colors that you can't imagine. So that's fun. The next group are the Pancrustacea, which are the barnacles. And you might be thinking, wait, these are crustaceans? I thought these were related to things like the clams and the oysters. I thought they were mollusks. No, they're crustaceans. And if you look inside them, they have gills and claws. They have legs, all that fun stuff. Darwin's least favorite group, because he just couldn't wrap his head around why these things even existed, because they were just so bizarre. But those are the Pancrustacea, and generally speaking, it's the Malacostraca and the Taxonomy that people eat. All these other crustaceans that refer to, as shellfish, all these other crustaceans aren't really on the menu, mostly because they're so small. The next group are the copepods, and this is probably one of my favorite groups because they're so colorful. So this is a drawing from Ernst Haeckel, and he had a number of books, I think it was around in the early 1900s, where he did the art and nature, art forms in nature, and he illustrated a lot of deep sea creatures. The copepods are very, very small animals, very, very small crustaceans that generally live in saltwater and freshwater, swimming around in the water column. And they make up a lot of like I don't want to call them plankton, but they make up a lot of the biomass of the creatures that live in the water or get fed on by whales and things like that. But Ernst Haeckel, if you don't know him, did a lot of this art, and he did a lot of these illustrations about how colorful and crazy these little crustaceans are. And you might be thinking, oh, well, he took a lot of artistic liberties with this. But no, he didn't, because this is, this is a photograph of what they look like. Or they're extremely, extremely colorful. They're extremely and extremely common. Again, if you just take a sample of lake water or whatever, or river water, and get a big scoop out of the water column or some of the sand in the bottom and start looking through them, you will find these little things swimming around. They have their little antennae. These things on the end are their egg sacs, which they frequently will bear with them as they swim around. They generally are extremely small, though. You may need a microscope to be able to see these. They're generally about 2 millimeters in length, so extremely small, although some copepods do get much larger. And by much larger, I mean 1 centimeter. So, a third of an inch or so. So you will have trouble seeing these guys. You wouldn't necessarily assume that these are crustaceans just by looking at them. But they are, and you should definitely know that they exist. Their presence in water is generally a sign of water health, and they're generally really cool. Related to them are the Ostracods. The Ostracota, these are the water fleas, is that what they're called? Seed shrimp, sorry, not water fleas, seed shrimp. Seed shrimp. These are also very, very small. So this, you can see here, this is 0.5 millimeter. They're itty bitty. They kind of have the body structure of a clam in that their body is divided into valves, one on the left, one on the right, and they live within, or their main body is within this valve, so they kind of they use their body to form their own shell around them, and they'll paddle along with their little cilia. They're very, very small. Again, you're going to need a microscope to see these things. You wouldn't necessarily assume that they are crustaceans, but the majority of the crustacean groups are in fact microscopic. And then finally, we have the Branchiura, which is a very small group. It's just one family, the Argulidae, and these are the carp lice. This is a group of entirely parasitic crustaceans. This is the carp louse on the side of this fish. They are parasitic on fish. They will live on them for a couple weeks before reproducing and falling off. There's just one known family of them. But they are strange enough that they kind of have fallen into their own, I guess you would say, class. These are class specifications. So these are the Argulids, or the the Branchiura, and that is all of the crustaceans. And that's all. I'm not going to spend a million years talking about the crustaceans. The 20 minutes that we've talked about it now is probably fine. And next time we're going to go directly into the hexapods. So we will talk about the entonaths, which are kind of the primitive insect-like hexapods that are generally considered, once upon a time they were actually in the Insecta, but these are prolific. They're microscopic insect-like creatures that are frequently found in your garden soil. And then we'll talk about the most primitive insects. Until then, I'll see you guys next time. Thanks.